Shri Gurubhyo Namaha children. Today we are moving on to the next part of electromagnetic induction, which is nothing but alternating current. Now in our last topic we were discussing about the orientation of the coil. Now whenever a coil is rotated in a magnetic field, an alternating EMF is induced and hence an alternating current flows in the circuit. So this is what we were discussing in the orientation of the coil. So what is this alternating voltage or what is this alternating current? Alter means to change. Every half cycle, if the direction of the current or the voltage is changing, you call that voltage or current as an alternating EMF or an alternating current. So it is nothing but the voltage which changes its polarity in the sense between positive and negative. Okay, for the first half cycle you will have the polarity, and the second half cycle the polarity will change. So for every half cycle, if the polarity changes with respect to time at regular intervals of time, if the polarity changes, then you call that voltage. Okay, you call it as an alternating voltage, and the resulting current also changes its direction. So the resulting current is called as an alternating current. So we are going to go in detail about alternating voltage and alternating current. So today's topic is electromagnetic induction and alternating current. We are moving on to alternating current. Now look at this diagram. Now here there is an alternating voltage source. Okay. Now this is the symbol for an alternating source. Now this is connected to a resistor R. Okay. Now here the upper terminal of the source is positive. Now here you have a positive sign. Here you have a negative sign. Okay. Now you allow current to pass through it. So the current flows. Now look at the direction of current here, children. Now the positive terminal is here. The negative terminal is here. Right. Now when I connect this to a resistor, now this is a load resistor. Now this may be a fan or a fluorescent lamp, whatever load, external load you are connecting it to. Okay, so that is resistor. Now as soon as this source is connected, immediately there will be a current flow. Now here the current flow is in clockwise direction. Look at the direction of current. It starts from here. Now this is the clockwise direction of current that is flowing through the circuit. Now this is the clockwise direction, right? Now after a short time, okay, now what happens here? The polarities of the source is reversed. Now here it was positive, negative. Now the polarity is changed. Now the polarity of the source is reversed. Now look at the direction of current this time. Now here it starts from positive. Now here you have the positive terminal. So the direction of current is now in the anti-clockwise direction. Here it is clockwise direction. Now here it is anti-clockwise direction. So what is happening here? The current is flowing in alternate directions. So when the current is flowing in alternate directions in a circuit, you call this current as an alternating current. Okay, right? Alternating current, and the voltage given is called as an alternating voltage. Is it clear, children? Now when I draw a graph, okay, now the graph, now this is the graph for an alternating voltage. Now here is a graph for alternating current. Okay, so you will be having a waveform of, like, now this is a sine wave, right? Now if the waveform of the alternating voltage is a sine wave, now these waves are nothing but you call it as sine wave, then you call this voltage as sinusoidal. Look at this spelling, sinusoidal alternating voltage. Now here the voltage alters for every half cycle. Now you have the values theta along the x-axis, because we saw that in the orientation of the coil the angle was changing. Suppose if this is going to be the coil, initially the coil was like this, which is 0 degree, then 90 degree, then 180 degree, then 270 degree, and then 360. So you rotate it for 5 different angles. So whichever is the independent variable, here theta is the independent variable which is drawn along the x-axis, and which is the dependent variable, here it is voltage. So for different angles, when you rotate the coil, you have different voltages, you have an induced EMF that is produced, thereby you have an alternating current in the circuit. Now here when I draw a graph, now this is a sine wave, and the voltage that is produced is called as a sinusoidal alternating voltage. So this is the voltage graph. Okay, this is a sine wave which is in red color. It is a voltage alternating voltage sine curve. Now thereby the current will be flowing in a whose value is given. The voltage here it is given as V is equal to Vm sine omega t. Okay. Now what is this Vm? Vm is nothing but, you call it as the maximum voltage. Now this is the maximum in the positive half cycle. Now the voltage keeps on increasing along this curve and it reaches a maximum at this point. Let me name this point as A. So this is the maximum voltage which is represented as Vm. Okay. Now what is this V? Now let us take some different points. Now instantaneous voltage at difference, but now you can see from this point, from this curve, the voltage keeps on varying, it keeps on increasing. So at different points you have different voltages. So at this point, if I want to calculate the voltage, I call the voltage at this point as instantaneous voltage. What is the voltage called as? This is called as instantaneous voltage, and it reaches a maximum which is called as maximum value. Okay, and what is omega? As you know, omega is nothing but angular frequency. Whenever we talk about varying voltage, that is alternating voltage and alternating current, you go for what is called as frequency. So omega becomes the angular frequency of the alternating voltage. Okay, now when this voltage, when you apply it to a closed circuit, you apply this voltage to a closed circuit, so the resulting current is called as an alternating current. So this is the graph. Now this is again a sine curve, and you have the maximum value for current. Now here also, as I told you, now here you have maximum positive, here also you have maximum but in the negative direction. Same thing applies for here also. So the current that is produced, you call it as alternating current, sinusoidal alternating current. Here also the current reaches its maximum, and here also in the reverse, I mean for the next half cycle, for the negative half cycle. Now here you call this cycle as positive half cycle, here you call it as negative half cycle. So here it reaches negative maximum, and the current equation I can write it as I is equal to Im sine omega t. Now instead of omega t, I can also write it as theta, because theta is the angle. Clear? So what is Im here? Again, Im will be the maximum value of the alternating current, and you can see the direction of current is also reversed for every half cycle. So you call this current as an alternating current. Here also you say it as sinusoidal alternating current. Okay, so this is about the introduction of alternating current, and so far we have talked about different values of DCs, direct current, steady current. Now whenever you draw a graph for steady current, since the direction is the same, we can easily find out the magnitudes. There will not be any problem in specifying the magnitudes of currents as far as a DC is concerned or a steady current is concerned. But look at here, there is change in the direction of current. Voltage is alternating here, current is alternating here. So how to go about, how to calculate the magnitude of the voltage or the magnitude of the current as far as an alternating current is concerned. So to find out this value of current, we go for two concepts. One is mean or average value of AC. The other one is root mean square. So that we will be learning in the next topic. To start with, we are going to start with mean or average value of AC. So how to calculate the average value of AC, because the AC, as far as an alternating current is concerned, it changes its direction for every half cycle. So how to calculate the magnitude of current? So first is we are going to talk about mean or average value of AC. So we know that the magnitude of alternating current, it changes from one instant to another instant, because here look at this curve, the current is not the same everywhere, it keeps on changing. Okay, and also its direction. Now here the direction and magnitude of current is one value. When I go here, the magnitude and direction of current will be some other value. So the direction as well as the magnitude of the current keeps on changing. So during positive half cycle, from here, that is 0 to pi. Okay, from 0 to pi, you call this cycle as positive half cycle. So during positive half cycle, now the value of current is taken as positive. Then during negative half cycle, the value of current is taken as negative. So when you calculate the average value for one complete cycle, now imagine the value of current from 0 to pi as 5 ampere. Then in the negative half cycle, it will be minus 5. So how do you calculate the average values? When you calculate the average value of AC for one complete cycle, in the sense from 0 to 2 pi. When you calculate the net or the average value, it rounds about to 0. Yes or no? Here it is going to be 5 volt, here it is going to be minus 5. So when you calculate the mean value or average value of AC, it is 0. Very important, one more question. The average or mean value of alternating current over one full cycle is 0. So you cannot have the value. So how to calculate? Now I am going to tell you how to calculate the average or mean value. So here, since it is for a one full cycle, it is going to be 0. Now I am going to measure mean or average value of AC for first half cycle. Now here I can calculate the current for half cycle. Okay, so over one half of the cycle, I can find out the value of current. Okay, so this can be this voltage or the current can be used in both analyzing DC as well as AC circuits. So what is average value of AC? Now it is defined as average value or mean value of AC is defined as the average of all values of current. So I am going to take average of all values of current over a positive half cycle or negative half cycle. So in this way, I can calculate instead of taking the average values over a full cycle, it is easy to determine the mean or average value of AC over a positive half cycle or a negative half cycle. So I can find out the average value of current. I average is equal to area of positive. Now it may be positive or negative. Okay, area of, now for my convenience, I will write positive half cycle. Here you may have negative half cycle also. So area of positive half cycle divided by, how do you calculate the average? By the base length of half cycle. So what is the base length as far as this graph is concerned? This is from 0 to pi. Now this is the base length of the first half cycle. So I can find out the area of the positive half cycle divided by the base length of half cycle to find out the average value of AC. So to find out that, I'm going to take a small elementary strip. Now I have taken a small area of this first positive half cycle. Now if this is going to be a small portion, and here since it is the angle along the axis, x-axis, I will take a small angle which is called as d theta, that is from this position to this position, d theta. And as I said you, the current at any point, now here you have maximum current which is Im, but I have taken a point and the current at this point is taken as I. So what will be my area there? So I will start with area of the elementary is small, okay, so area of the elementary strip. So what is the area now? The area is, here it is d theta, here it is I. So the area will be I into d theta. Okay ma? Now I am going to find out what is the area of positive half cycle. Positive half cycle is equal to, I'm going to integrate this. Now if I integrate the area of the elementary strip, I will get the entire area of the first positive half cycle. So I'm going to integrate this value with the limits. So what is the limit I'm going to give? The limit is the base length, because initially it is 0 and finally it is pi. So I'm going to give the lower limit as 0, upper limit as pi, integrate I d theta. Okay ma? Now what is the value of I? I know the value of I is equal to Im sine theta. Theta is nothing but omega t. So substitute for I as Im sine theta. So this equation will be integral 0 to pi Im sine theta d theta. Okay. Now I am going to integrate. So what is integral? Now take this Im out. Im is a constant. Okay. So Im out. Now integrate sine theta d theta. Integral sine theta is minus cos theta, right? So cos theta with the limit 0 to pi. Okay. Now substitute the value Im, upper limit minus lower limit. Now here I have a negative sign, that I will take it out, children. So cos pi minus cos 0. Okay ma? So cos pi is 180, pi is 180. So cos 180 is minus 1 and cos 0 is 1. So when I simplify this, minus Im, I have here also minus 1, minus 1. So it becomes minus 2 inside. So when I bring that, now this will be minus 2 here. Now here already I have a minus outside. So 2Im will be the, what is this? This is nothing but area of positive half cycle. Okay ma? Now I am going to substitute this in the formula. What is the formula I wrote? I wrote the formula for I average. What is the formula for I average? I have written here. Look at this. I average is equal to area of positive half cycle divided by base length of half cycle. So area of, let me write this as I average equal to, what is the area of positive half cycle? Just now I found out. So here now let me write this I properly. So I average is equal to, what is the value now I got? 2Im divided by, what is the base length? The base length is pi. Okay. Now when I substitute the value of pi as 3.14, when I simplify 2 divided by 3.14, I have the value of average value to, average value of current to be 0.637 Im. So this is the formula for average value of current over the positive half cycle. Now this is nothing but 0.637 times the maximum value of current. So I can say in words, the average value of AC is 0.637 times the maximum value of the alternating current. Now this is for positive half cycle. If this is going to be for a negative half cycle, I will have the average value of current to be, instead of positive, I have a negative sign here, 0.637 Im. So this is for the negative half cycle of the current. Hope the topic is clear for you children. So with this, we are moving on to a very simple problem based on Faraday's laws of electromagnetic induction. Look at this problem. The magnetic flux passing through a perpendicular coil to its plane is a function of time and is given by psi of b, which is equal to 2t cube plus 4t square plus 8t plus 8 Weber. If the resistance of the coil is 5 ohm, determine the induced current through the coil at time t is equal to 3 seconds. So before we move on to solve the problem, let us write the values. Data has to be given, that has to be written. So psi of b is equal to, what is the equation children? 2t cube plus 4t square plus 8t plus 8. Okay. Now put this in brackets, write the unit Weber. Okay. Now resistance is given children. So resistance value is 5 ohm. Then what else is given? Time is given. So time is 3 seconds. Okay ma? Now you need to determine the induced current through the coil. Okay. So what is current formula? Current is I. I is equal to E by, actually it is V by R, but here we talk about induced EMF, so let me write it as E. Okay, so E by R. So induced EMF first has to be determined. Resistance is already given here. So first let us find out the induced current, induced EMF. So induced EMF formula again here, E is equal to d phi of B by dt. Okay, so I'm going to differentiate this phi of b. So differentiate. So what is the equation now? 2t cube plus 4t square plus 8t plus 8. So when I differentiate, this value will be 3 2s are 6. So it is 6t square plus 8t plus 8. Okay. Now for a time, now I have to substitute for time 3 seconds because time variable is here. So for a time of t equal to 3 seconds, what will be the value? I'm going to substitute. I'm going to substitute this in the equation. EMF induced equal to 6 into 3 square plus 8 into 3 plus 8. So when I simplify this, I have 9 6 54 plus 24 plus 8, which is 86 volt. Okay ma, so I have found out the induced EMF. I'm going to substitute in the current formula. So I is equal to E by R, which is 86 by, what is the resistance? It is 5. So 86 by 5 is 17.2 ampere. So the value of induced current is 17.2 ampere. So this is your book back numerical children. Please make a note of it. Okay ma? So I'll be solving a few more problems. We will be learning about RMS value of AC in the next class children. Okay ma? See you in the next class.